Hello, good morning, everybody, and welcome to the long-awaited Friday morning session. Just to give you a quick overview on the session, in case you do not know, we're going to have this session, and then there will be the general meeting results, together with a coffee break. So if you want to attend to the general meeting results, you have to give up on the first few minutes of your coffee break. The first speaker that we have today is going to talk to us about AWOLs. Please welcome Patrick with a big applause.
Yeah, welcome and thank you for joining this early session on Friday. This work was done together with Matthias, Lars and Tim from Technical University of Munich and Johannes from MPI. I am a guest researcher at Technical University of Munich and working at Benox. So let's start right away. What is Happy Eyeballs? So nowadays we have a lot of options when a client connects to a service. You can connect via IPv4, IPv6, you can choose between TLS or QUIC. The client needs to decide on which records types to query for. And nowadays, since ECH is now also standardized, it might also get more common to enable ECH or not. As a user, a normal user does not care about the protocol which is used to connect to the service. He wants to get the best possible experience, but we as technicians, we maybe want to get newer standards deployed but still reduce adoption hurdles. And for this, there's the algorithm called Happy Eyeballs, which does connection parameter prioritization in order to favor newer protocols, but still keep the user happy. So, but why is it important for you? Currently, there is standardization of version 3 ongoing at ITF, but still, you might think this is a client problem. So most of you are operators, so why should you care? This is what I will show you in this talk is that this is important for user experience, and that some of you, for example, who operate resolvers, might learn something which can be useful for the users. What we see is that different browsers and OSs behave differently, implement different versions of it, and that has different impact on how the user experience specific network conditions. And in certain edge cases, we also see that there is significant user impact. So our main contributions are that we develop different test cases for different aspects of the Happy Eyeballs algorithm. We evaluate existing implementations and also newly developed ones in nightly versions. We created a web-based tool to check each browser which has JavaScript capability on Happy Eyeballs implementations, and we have black box measurements in a testbed to validate these. So to give you a short background on what Happy Eyeballs actually is and how it works, in version 1, standardized in 2012, it was standardized that it wants to prioritize IPv6 over IPv4, and it does that using a thing called the connection attempt delay. So you first start your IPv6 connection, in this case a TCP connection, then handshake, and then wait for something called the connection attempt delay. And only if you don't receive a response within this connection attempt delay, you fall back to IPv4. This connection attempt delay is usually set to 250 milliseconds, or recommended to set to 250 milliseconds. And so the user will barely notice this fallback and still get a working connection if IPv6 is broken. In version 2, the ITF added more additional logic to also handle the DNS resolution. So version 1 expected that there are IPv6 and IPv4 addresses already available. To get this, we need to resolve them, and they defined that both quad A and A records should be resolved. the quad A query should be sent first, and then the quad A query should be sent. And if the A response is received first, then the client should wait, something like called a resolution delay, to see if the quad A response arrives. Only if it does not arrive within this resolution delay, it falls back to IPv4. So our approach was to have the client as a black box. So we don't know what happens at the client. There are implementations where we don't have the source code of, so the client is a black box. Our server is configurable per test case. And additionally, for the resolution, we also implement a custom name server. Our web-based tool should be easy to use, so everyone can just go on it and run some measurements to get results. And it's intended to collect results in real networks, on real devices, with real browser setups, because we know that there's a wide variety out there, and we cannot cover them in artificial setup environments. But on the other hand, these measurements in real networks can be influenced by caching, which is not always under our control. We try to reduce it as much as possible, but we also performed local testbed measurements to see that what we see on this web-based tool also is confirmed on such an artificial environment. Finally, our code is all open source, and we are also actively developing and adding new features to this tool. We are also looking out to host additional instances. So this is a call for action to, if anyone has some resources and is interested in, we would like to host somewhere, some instance somewhere else. Currently, it's only hosted in Munich. And since this is a latency sensitive algorithm, sorry, it might be beneficial to also have it in other places of the world to get more significant results there too. So let's start right into the first test, the connection attempt delay. We implemented this connection attempt delay by adding a delay on the server side for IPv6, and we did that by setting up different IP addresses with different delays per IP address. So that's quite straightforward. Our server delays based on the destination IP you are contacting. Looking at the results, this is what our website looked before one of my students improved the UI a lot. But it basically stays the same. On the top, you see the delay which is applied to each connection, and each line is basically a new measurement run. What you see is here Chrome, and you see that it uses IPv6 up until to a delay of 300 milliseconds, and then falls back to IPv4. And this is a static delay. We always, for each connection repetition, we always see the same behavior. For Firefox, it's very similar, but the connection attempt delay is not 300 milliseconds, but 250 milliseconds. So Chrome and Firefox are quite simple to interpret and to how they work. Now, going over to the third major browser engine developer, Safari, there we see a very different picture. So what we see is that in general, it prefers IPv6. But as we increase delay, there is no clear picture. You see switching from v6 to v4, and then back to v6. Here we see a maximum delay of 600 milliseconds used where still IPv6 was used. And I can tell you that we even observed that IPv6 was used up until to a delay of 2 seconds. This is called dynamic connection attempt delay, and is also standardized in the RFC. We also talked to Apple. So they confirmed to us that they do it dynamically. What they told us is that it's not domain-based, but actually prefix-based. But this still does not explain what we see here. For example, for 300 milliseconds, we see in the first run v4, then v6, and the fourth run, we see again v4, although the IP address is always the same. It's just different domain names to prevent caching. So there is still a pattern to be found. We don't know the algorithm since the It's not public as far as we know. But yeah, so this is also a behavior where you might see interesting, unexpected results compared to how Chrome and Firefox currently behave. Now, this was the connection attempt delay, where IPv6 was raised against IPv4. Going over to the resolution delay, what we did is we implemented a custom resolver, and we encode the resource record type and the delay in the domain name. And our name server then delays the response by what it's configured in the domain name. And this way we can then check what the client connects to. Now first, Safari here, this is the simple case. The first line is delaying the A record, the second line, the quad A, and then it repeats basically. What we see is if we delay the A record, Safari does not care. It always uses IPv6 because the quad A record returns immediately. If we delay the quad A record, we see it will still use IPv6 up until to a delay of 50 milliseconds, and then falls back to IPv4. This is exactly what the RFC says or what it recommends. So this is what one could expect reading the RFC. Now, Firefox, again, very different. What we see here is not a resolution delay. What we find is that neither Firefox nor Chrome implement resolution delay, but Firefox even has a more specific behavior. So both wait always on both responses to return. So Chrome as well as Firefox, if they issue quad A and A queries and wait for both to return, so they have already very long measurement runtimes. And Firefox even fails on some cases where the A record is delayed for too long. That's what you see here with the error. This is even though the quad A record and response returned, so it could connect via IPv6 directly. So what we see is Firefox, and this is not only true for Chrome, but all Chromium-based browsers. So we tested different ones. They don't change the behavior with regards to happy eyeballs. And in their current stable version, they do not implement any resolution delay. And the outcome is that the DNS resolver's timeout will decide on how fast a page will load if there is a delay on the A record. So what our suggestion is here, if you operate resolvers, check your timeouts and see if it can, if the timeout is set to a sensible value, and or if you might want to lower it to improve the user experience in these edge cases where one record might be delayed or unavailable. Furthermore, something which I did not show you here on the slides is that we also found that there is different behavior in certain proxy and tunnel setups, especially with iCloud Private Relay, which is in principle a two-hop relay with different egress operators. Two of them are Akamai and Cloudflare. And so even though you are using Safari, you have at least 3 different behaviors without the iCloud Private Relay, which is what I just showed you. And then, depending on the egress operator, you will also see different behaviors for Akamai and then Cloudflare. So that means that the client and the network configuration are relevant to what you measure and what you see. Going on from this, we decided to also measure resolvers. So how do resolvers actually connect to our authoritative name server? And what do they use? First, we checked which record types do they query for. Do they even send quad A records? And is the quad A record received before the A record? We did this for resolver software, so for bind, unbound, and not, and also for some public resolvers. What we see is bind sends both record types, but always sends the A record first and the quad A record after. But bind then still always will use IPv6 if a quad A record is provided. This is unlike unbound. Unbound always sends the quad A record first, but will only in 44% of the cases which we observed. So maybe it's some randomness in there. We don't exactly know why it shows it, but it's not always preferring IPv6. It seems to sometimes use IPv6, sometimes use IPv4. For not, we even have a different behavior. It will either issue A or quad A queries, but not both at the same time. And then also use quad A and then in the end IPv6 only in not even 30% of the cases. The next columns are what we observed, the delay until there is a retry observed at our server. And the number of IPv6 packets tell you if there is a timeout experienced, if it falls back to IPv4 directly, or if it retries IPv6. So for unbound and not, we see that it retries once, even so with IPv6, so it does not have an direct IPv4 fallback. For the public resolvers, we have a very interesting result, in my opinion, for Google Public DNS. Google Public DNS will, for an uncached zone, not issue a quad A record for the name server name until it first resolved or finished resolving this query, and only after responding to the client or to the client, it will issue the quad A record. We assume for future queries into this zone to be able to use IPv6 then, but it will never use IPv6 if it's uncached. Cloudflare, Quad 9, and OpenDNS all send, according to our observations, Quad A queries first and then A records. But Cloudflare and Quad 9 only use in 11 and 34% of the cases IPv6, while OpenDNS always prefers IPv6 if it's available, and it uses a timeout of only 50 milliseconds, which is very different to what we observe with any other resolver operator. OpenDNS also implements fallback to IPv4 on the first timeout already. So the takeaway for us is that connection property selection is not only connection property selection and the prioritization is not a web-only issue. The DNS protocol, but also if you think about mail and other protocols, they might also need to think on if they want to prioritize protocols like IPv6, and for DNS, if DELEC is standardized at one time, if it wants to use different DNS protocols to communicate with the authoritative. So what we think is, while Happy IVOS is for web, standardized for web use cases, other protocols might also think and want to standardize such prioritization algorithms for their exact use case. Now, going over to Happy IVOS version 3, Happy IVOS version 3 now includes all these more complex options, which I told you in the beginning, quick and ECH, for example. This means also that we have a multi-layer decision. So we require a prioritization list. You can choose between IPv4 and IPv6, but you can do quick on IPv4 and IPv6. So you have a matrix of options, and you need to prioritize these. That means a higher complexity. And what we did here, we implemented a number of tests, and we are currently still working on new tests. So if you have input, please tell us. So one test is just, does your browser even support Quick or HTTP3? Because if it does not, the other tests don't really make any sense. Then we have a simple Quick versus TLS test where we delay one protocol and see what happens. And the final test is the most complex one, where we basically delay the protocol handshake, so Quick or TLS, and also the IP version. Now I want to show you a short demo of exactly this from our website. Yeah, so here you see our website, and do you see the different tests which you can select from? And like I said, we now want to look into this combined Quick and IP version delay test. So at the beginning, you will also see some explanation of what it actually does so that you can understand it. And here you have quite a number of options which you can configure to, but usually there are sensible defaults. We also have some explanation text for you to understand what this option does. In this test, I'm reducing the number of tests a bit to have a shorter and more showable demo. And what you see here is, as soon as you press run test, it will run the tests, and this is Firefox nightly, and it will prefer quick over IPv6. If you delay quick, then it will fall back to TLS. If you delay IP, it will fall back from IPv6 to IPv4. And if you delay both, you get TLS over IPv4. So this is exactly what you expect. This was not the very first version which Mozilla implemented, but we were in active contact with them, and this is what you would expect from what's currently thought of. Okay. Then coming to conclude my talk, so Safari only Safari implements version 2. No other browser yet supports more than the connection attempt delay, but all 3 browsers are currently working on, or engine developers also are working on implementing version 3. Chrome has a feature flag to enable this. Firefox, you can enable it in the nightly version. And Apple told us that they are working on it. So we don't have more insight into that. But what we see is, if you use our measurements, what's important is that not only the client and the OS might be important, but it's also the network condition you're in. Do you use proxies or not? Then the resolver timeout. So if the no resolution delay is implemented, the resolver timeout can heavily impact how the user experiences a service. And our next steps are now implement more test cases, especially with Happy Hours version 3. You have a huge parameter space where you can have multiple different tests. And like I said, we are looking out to have different vantage points. So if you have any ideas on what we might add, or have some resources where we can deploy such an instance, please contact us. Now, open to questions. Thank you.
Thank you, Patrick. Okay, do we have any questions? All right. Please state your name, affiliation.
Lee.
I mean, say 4. You know the drill.
I know the drill. Lee Howard, happily retired. First of all, brilliant work. This is fantastic. Really good news for the internet. Really, great to see this research. Thank you. I guess I have 2 questions. One is, do you have an opinion based on this on what method, what variation would provide the best user experience? But the other question is a little bit more technical, maybe more interesting, is in Android phones, there's a software CLAT that I believe is adding some latency when connecting through the CLAT. I would love to see if that provides a different experience. So Android versus desktop. Hi, Jen.
So
sorry to be getting in the way of that one. No,
okay, so preference, what I think, it's a good idea to have something like Happy Hours, to have a guidance for clients on what you should prioritize based on measurements you have done, based on best practices. I think that's a good idea in general, because, yeah. For your comment on Android and CLAT, that's exactly why we created this web page, so everyone can bring their devices in certain network conditions. We don't have it yet, but yeah, I agree. That's exactly the reason why we did it on a web page with a simple to use way. So basically everyone can do it on their own, can bring your devices in your own network conditions you're interested in to see what happens. We also have, so on our new version of the web page, you also have like debug insights. So if you hover over a specific delay, we will see when the client connected to the server and the delay between fallbacks and so on. So I hope this helps.
Greg Choules, ISC, back to slide 14, if you would, please. That's not a quick one. I'm just curious about your bind results.
Yes.
And if you want to talk to me afterwards about it. Just don't know how you got to that conclusion. That was all.
You mean how we measured it, or?
No, how it was that you concluded that bind sends the quad A after the A.
So this was in a local testbed measurements. We use the current stable bind version and just looked in TCP down what's first, or what, and also what we receive at the server first. So
Interesting.
there's maybe there's a newer version which we did not use. So I would have to check which exact version we used. But this is so the resolver software side is always like what we deployed locally and what we observed there. So that's how we concluded it for the resolver. It's a bit more complicated for the public resolvers, but for the local ones,
I just love to see the PCAPs and the config at some point. That's just
I can try to.
Jen Linkova, network engineer at Google, and someone who keep disturbing Happy Eyeball working group. So Lee, I'm not sure why you're specifically focusing on Android when like CLAT is actually implemented in like all Apple products and so on, right? So actually, again, we all know that like Happy Eyeball v2 only exists in Safari. Everything else is currently v1. For v3, however, we keep having a very long discussion, and I'm yet to produce a PR for v3 draft. And we had a like 2 hours side meeting in the last ITF about how exactly we're going to treat various scenarios of v6 only plus CLAT, and do we actually want to differentiate it or just consider it's a dual stack stuff, right? So because one of concern is you don't want your host and Happy Eyeball implementation to care, is it actually CLAT IPv4 address, or it's a real v4 address, and you cannot always actually tell that. So it's a bit tricky and it's work in progress, right? So you are welcome to, if you have strong opinions, I'm quite sure the working group, which is actually quite active, will be happy to hear your feedback.
All right. Yeah, then thank you, Patrick. A huge applause. Next, we are going to have 2 lightning talks. And for the first one, I want you all to welcome Warren and Drew on stage. And yeah, take it away.
Slides. Well, while we're getting slides, hi, I'm Warren. This is Drew. I'll start talking, I guess. Yes. Yay. Yeah, hi, everyone. I'm Dhruv. I'm the Internet Architecture Board Chair, and we are here to talk about a workshop that we did. And this is the report of that workshop that is under community review right now. So we would want feedback from this group. So that's why we are here. So let's start. For those who missed the BOF, this is just a quick introduction of what IAB does. We are the body that provides long-term technical directions. We want to make sure that the internet continues to grow and evolve and make sure that the architectural guidance and technical foresight is there. And one of the things that we do is pre-standardization workshop as an activity. While ITF is focused on drafts and RFCs, workshop is a way for us to just have a much more longer focused conversation, sometimes over multiple days, and we can go and deep down. Whereas if you have attended an ITF session, you know how we move from documents to documents, and the discussion pace is very, very different. So IB workshops allows us to invite folks who are sometimes even missing at an ITF meeting, and we could have a much more like in-depth discussion, and sometimes even with Chatham House rules or other mechanisms where we can have more frank conversations, which might not be always possible in a public forum. But at least for this workshop, it was a virtual one, and it was recorded, and all the materials are available. This workshop aim is basically so that we can gather more inputs and sometimes explore, and then hopefully that leads to more work in the ITF, either in working groups, new working group, or a research group, or giving more direction back to the community. So this workshop, we had it in December. We had around 67 folks participating virtually. There were 30 accepted submissions. The report is out and it's under community review. And all the material is available if you want to go and check it out for more details. The way we ran the workshop was the first day we focused on what is the current use case, try to figure out how people are actually publishing the information, how they are discovering it, how they are consuming it. Are there any ideas for improvement? What would people like to see changed? And what is the future direction? Where is this going? And with that, let me pass it on to Warren.
Hi all. So I'm going to be going through this fairly quickly because we would like some time for questions. So what are we actually talking about here? I think most people are aware of what geolocation is, or IP geolocation, but a little bit of background on what it was originally designed for. Initially, the primary use for this was to try and get people to a data center that's relatively close to them. So basically, if you're in Edinburgh, we'd like to get your traffic to sort of, Edinburgh or links, not serve it from a data center that's in Sydney. Once we started deploying that, people started using it for a bunch of other things, right? Once it was deployed, people figured out if you're, for example, Papa John's and somebody searches for a pizza shop, you should try and give them give the person an answer somewhere in Edinburgh and not, for example, in New York. It then got expanded for a bunch of other uses. So if you only have the rights to distribute a video stream for a football match in Spain, and somebody's trying to access it from Germany, maybe you shouldn't provide that content to them. It has then been also sort of tried to be bent and used for other things. Like, for example, on this side of a bridge, you're allowed to do online gambling. But on this other side of the bridge, you're in a different country and you're not. So what IP geolocation is being used for isn't really the original use case, and it's probably not well suited to the new use cases. This is basically the same thing, right? Originally, it was a network level thing, but it's trying to be used as well for enforcement and much more highly targeted location info. For example, contractual stuff, and law enforcement also potentially would like higher resolution stuff, potentially for things like if you make a VoIP call to emergency services, they might want to be able to actually deliver the ambulance to you and not to sort of the city that you're in. How does geolocation work? It was originally written up in this RFC, and it's a CSV format. So it's literally prefix, country, region, and city. At one point, it also had postal code, but that is deprecated because when we wrote it, we figured that was much too targeted, right? It tended to be less granular than that sort of thing. So network providers would put their CSV or their geofeed file in a big CSV file and publish it somewhere. But that's not really helpful because if people don't know where the file is, you can't actually get the info. So there's this other RFC, which allows you to publish the URL for a geofeed file in IRR data, basically. So somebody can download the entire right databases from other RIRs, walk through them, collect all the URLs, then go and fetch the files, collect all of that, and then you have a mapping from IP address to location. If you don't want to do that work yourself, there are a whole bunch of geolocation providers who will do this for you, often at a fairly substantial cost. Or Massimo Candela, who I think has left, has a site called Geolocate Much, where he's already done this work, and you can just download the geofeed, all of the geofeed files sort of in one big signed blob. So we had this workshop, and one of the exposed a bunch of concerns. One of them is it's not entirely sure what the location actually represents, right? If you get a thing saying that this prefix is in the IECC in Edinburgh, is that where the user is using the IP addresses? Or is that where the CGN that the user is behind is? Is that like where your network egress point is? Is that just where the org ID happens to be registered when the person got the address block? Or is it maybe just kind of the country that it's being used in? But there were a bunch of other things also that were located or sort of exposed as gaps. IP addresses don't really have a geography. They move around. They weren't originally intended for this sort of use. The CSV format also doesn't have anything saying when the file was last updated. So if you've got a GeoFeeds file that's 10 years old, is this still actually valid? If it was updated last week, probably it's more likely to be valid. But another one, and I think this is really important, there isn't really user consent for this. Your network publishes it. And if it's just publishing, this address is kind of used in this country or city, that's probably fine. But now that it's being used for much more targeted, much higher resolution things, should the user be involved? I think we still have some time, even though it's gotten to...
Older timer.
That's the older timer. So why did we have this workshop? Well, it's clear that IP geolocation isn't going away, but also it's not really well suited for some of the current use cases that people want to use location. An example is we seem to be seeing more satellite networks. If you're sailing a boat off the coast of Edinburgh and you're using Starlink to make a call to the Coast Guard, should the Coast Guard show up where the boat is? Should they show up where the satellite downlink is? Or should they show up for like where your house was when you bought Starlink? Clearly one of these is the right answer and the others aren't. So there are some changes from the workshop. One of them is it was fairly clear that people don't like the CSV format for GeoFeeds, right? CSV is annoying to parse and it's not very expressive. So actually on Monday, I submitted a new draft, which is the same GeoFeed stuff, but in JSON and with a new mandatory last updated time so people can have some time. A lot of people want to add additional info to that. But also, we're looking at doing things like adding new mechanisms so that this can be signaled in HTTP or through an application, and then the user hopefully will have a lot more control over this. So if you're trying to buy a fishing license, possibly all that the provider needs to know is you're roughly in this country. Whereas if you're trying to find the nearest pub, possibly you need higher granularity, and maybe browsers and phones and similar can provide you a control to send how much info you share. So next steps, there's going to be some more work. There are some drafts coming out of this, but also this is ripe and there is an address policy discussion, there's database discussions, etc. This is where people who actually understand addresses and how they're used and deployed show up. So, we'd like your input as this work progresses. Please participate. And I think we have a tiny bit of time for questions. And apologies for going through this so quickly. And I have a laser.
Lee Howard, happily retired. I'm not sure that I heard in the workshop that people didn't like CSV as a format for this use case. I heard that the current version was insufficient. So I just want to slightly recharacterize that. It is my personal opinion, and I have said this, that the first use case that you provided of using latency to infer where the nearest data center is, that's architectural. That's not even geolocation. That's latency. That's using the network to provide network performance. Great. Everything after that is about adding the metadata on top of and saying Edinburgh as opposed to saying 11 milliseconds. And there's a little bit of nuance there. I only like that original case. All the rest are adding metadata that doesn't belong there.
Yeah. So a quick clarification. What I'm saying is for getting users to the close thing. Originally, providers were publishing the geo feed, so a CDN could know, when a connection comes from this address, let's use this one. But yeah. So.
Okay, right. Thank you, Kenny Huang, Chair of APNIC Executive Council, speaking in my personal capacity. And based on the GeoFeed, basically all the RFC standard already standardized all the requirement. And also that was accommodated into the WHOIS and the database service within either in APNIC region or either in RIPE region. But actually the coverage within all the different regions was very insignificant because the coverage less than 1 digit. So is any other way we can to promote a member to have a GeoFeed information within the WHOIS database? Thank you.
So if you go to geolocatemuch.com or .net or .something, search for geolocate or geolocate much. Massimo actually has a bunch of stats published on his page, and it seems that it looks as though there's very good uptake, at least of the people publishing geofeeds. The more recent RFC, where you publish a attribute in that isn't getting quite as much uptake, but it is still fairly significant. So maybe we can chat more later about stats.
Greg Choules, ISC. Regarding the point about taking users to the nearest data center, we see a lot of use of ECS in DNS specifically for this point. There was a talk earlier in the week, or at OAK, I can't remember, about in IPv6 effectively obfuscating your location by using dynamic IPv6 addressing. So that doesn't help an awful lot. That's going to make things worse. And just a point on, should we be using IP addresses at all? I mean, you kind of raised the point. I mean, why not just use your GPS location? Other satellite location systems may exist.
Yeah, I mean, what geolocation is being used for now isn't really the original use case and intent. And it feels like having some better solution, preferably where the user has a lot more control, is the way to go, right? Like having different services have different amounts of granularity seems really useful. There is, of course, the slippery slope argument. Like most apps on my iPhone require that I give them some sort of geo info or access to geolocation. And for most of them, I don't really understand why they need that. But if I don't give them the access, I can't use the app. And so, how do we do this in a way that people can choose what information to share, what granularity, and not be stuck in the, you have to do this or you can't reach the service.
All data is useful to somebody somewhere.
Great.
Yeah, true.
Thank you very much,
Thank
and
you.
come chat with us after if you like.
Yes, thank you.
Okay, thank you so much. There was another question. Please talk to you. No, you're really. It was sorry. Your speech was too interesting. I think that's the problem. Please ask the question directly. Okay. Now I would like to call Andre on stage. He's going to talk to us about ASPA. Stage is yours. An applause, please, to Andre.
Oh, hello. Hello. Let's continue in this week of ASPA. We started on Monday. We had the ASPA working group, and now we have ASPA closing. I'm going here with the public service announcement about what we did this week in the RIPE meeting, which probably was not a good idea. For RIPE 92, we did ASPA signing and validation because, ASPA is the new kit on the RPKI block. So we were very eager to try it. So first of all, we assigned our ASPA object for our autonomous system that we use here, 2121. And it was very straightforward. I think it was actually the very first ASPA object that our RPKI portal created when it got live in November last year. Other ISPs started signing their ASPAs as well, so yeah, this is fine. And we of course started also dropping invalid ASPA paths in our network because that's what you are supposed to use ASPA for. This is something that almost nobody is doing because the support in big router vendors is not very good or virtually non-existent. But yeah, we use BERT, and you heard Maria's talk on Monday. BERT has now support for ASPA validation that actually works, at least to some extent, how we understand the drafts. Yeah, and maybe after this talk, you won't be doing the same thing that we did. So first of all, how does our RIPE meeting works? It's a stub network. We have our ASN, we have our IP addresses. Usually, we are connected to only one upstream ISP that is providing us not with default route, but with full BGP table. We explicitly ask for full BGP table so we can do ROA validations because that's what community asked us for a while. So we basically validate the ROAs, and if we find that some prefixes originated from invalid ASN, we just drop it and we will not put it into our routing table. This works for years without issues, even though it's a little bit debatable whether it actually has any effect on this single home stub network. And we did ASPA validation this week because it was like the obvious thing to do. Well, And then I asked on Monday whether if you see something that doesn't look right, talk to me or text opsmetg@ripe.net, we'll sort it out. So I got the first report from the other Andre that you know, the chair of RIPE and CC board, who's from CZNIC, and he complained that he cannot reach CZNIC over IPv6. So I looked it up and I found out that we don't have the root in our router because it is ASPA invalid. Why is it ASPA invalid? Well, because our ISP has also signed their ASPA, and CZNIC also did their homework and signed their ASPA. Both I have a list of tier 1 providers that they are providing their service, but both of them are also peering with this AS6939, which is a very well-known ASN of Hurricane Electric. And this network is quite known for providing free IPv6 transit. So basically, but because it's free, there is no contract with them, of course. They are not listed in either side's ASPA list of providers. So what ASPA sees on this is basically the textbook example of root leak by a peer. Like there's a peer of those two which is leaking traffic. So this is exactly the volley in the volley free routing concept of ASPA. So both our ISP and the destination are peering with the same party. Neither of them consider them their provider, but they do act as a provider and they actually do a good job. They deliver the packet, so it's not just a configuration mistake. They are doing this job of provider. So ASPA is doing the right thing. This is the root leak, and it was prevented by ASPA validation. So where's the problem? The problem is that, of course, this is very likely not the only path from here to CZNIC. There are probably also other paths that are going through the approved providers. But if our ISP is not dropping ASPA invalids, they are only sharing the best paths with us. We don't see any other path than the best one. And the best one is going through this peer, which is not their provider. So if we drop it, there is no other alternative path that we could use. We will just end up with no route. So how we fixed it quickly? Well, when I explained Andre what exactly is the problem, he just went to ASPA portal and add the Hurricane Electric into their providers. The ramps are now touching, everything is fine, and the nice experience was that it took only 10 minutes from clicking in ASPA portal into our forwarding information base. So the changes in the RPK are quite fast to propagate. There's a link to ASPA Pathway Viewer if you want to see it, how it looks. It's probably the picture is better than lots of words. Anyway, the point of my talk is that, yeah, the ASPA validation is a good idea. You definitely should validate your customers, your peers, your redundant links, all the links that are basically, that if you lose the route, you will find an alternative way. But if you have a transit of last resort and you will start dropping ASPA invalids, basically the two options that you have is that if you drop them, you will end up with no route, and it's your problem to solve because your router is dropping the traffic. But if you send the data anyway, the worst thing that can happen is that your ISP will drop it because there's some route leak or whatever. But it means that, yeah, it's your transit problem, and you basically pay your transit to deliver the packets. And it's the last resort of transit of last resort. So that's basically what you are supposed to do. So for me, it seems like B is actually the better option here. And in case of our single-homed network, basically we only have the transit of last resort. This is our only BGP neighbor. So with that, I am some call to action. So go there, sign your ASPA, but please keep the data up to date and validate your customers and peers. For your last resort transit, maybe not. And now I believe I have some time for comments, questions.
Yeah, thank you, Andre.
I see you're already queuing from the beginning.
So we also have like an online participation. So I think we should do this maybe first. I think.
Can somebody grant the microphone to the person in the queue then?
Yeah, so.
Who's the chair of this session? Somebody who's chairing the session in Meeteco has to press the green tick.
Please,
Otherwise,
please chair the session.
Or maybe somebody at tech desk could do it. Just giving you tips. Yeah.
Okay.
Oh,
Hi,
shit.
Rüdiger Volk, retired, and
30 seconds, Rüdiger.
oh, okay. Oh, yeah. Well, okay. What we are seeing here is kind of when ASPA had one of the final rounds of discussion, it decided that, well, okay, the IPv4 and the IPv6 AS topology is assumed to be the same. It looks like the Hurricane Electric thing in the real network has been overlooked, and that's actually the proof that the topologies are not the same, and there are consequences to it, unfortunately. Sorry.
Maybe. I still feel like this is basically an example of a root leak, and it doesn't matter. If Hurricane Electric provided IPv4 transit as well, like nothing would change conceptually on what happened here.
All right. So I guess we can maybe take the next question. Okay, you queued first, and then we will bounce back and forth there.
Job Snyders, would you mind going back to slide 4?
654, yes.
I'm a little bit disappointed in this presentation in that I feel that you attribute the problem to the wrong aspect of the graph. And I think spreading information that you should or should not do ASPA verification based on a wrong interpretation is harmful to the project. In this scenario, the destination either misconfigured their ASPA and resolves it by configuring their ASPA correctly, or they conclude Hurricane Electric is leaking the route, we will disable the peering with Hurricane Electric. Concluding from either one of those options that the problem is with 2121 doing ASPA verification on the routes, I think that does not logically follow. The problem really is between Hurricane and the destination. So telling the audience like, hey, we should not have done ASPA verification, I'm like, no, either the destination should configure the ASPA correctly, or Hurricane should not provide free transit without authorization of the peers whose prefixes they are propagating. But the conclusion like, oh, the problem is with the right meeting is like, no, that is where the symptom manifests, but the problem is on the right side of the graph. And I think framing situations like this needs to be done really careful in order to not discourage the community from using ASPA for its intended purposes. And your conclusion that dropping ROAs or dropping routes that are invalid based on the ROA is not a problem, but with ASPA it is, I think that is not a correct conclusion. I could not reach my ROA invalid destination, but I just don't complain about it because I either need to fix my ROA, you know, or no. So why, it's the same. If you can drop ROA invalid routes, you can do the same for ASPAs, and the problem is the remote site. There you must fix the problem, if you consider it a problem.
Yeah, I understand your point, but the biggest difference, and that's maybe what I wanted to point out here, is if there is the origin, there is the wrong origin with ROA validation, it's wrong. Basically, you see it from everywhere on the internet, but
only from the networks that do validation. It is the same. It's the same principles.
No, it's not, because the problem is that there is definitely a path that is authorized between our ISP and the destination, but we will never see it because the non-authorized is shorter and it's better, and we only get the better one into our network. So we cannot see that there is other path that we can actually send the data other path.
I think the point worth reiterating is you are single-homed, taking in a routing table without default route. You're filtering out things from that routing table, and you have a partial routing table as a result. And whether that's ROV-based or ASPA-based, that's irrelevant.
Okay, so Maria, you're next, and then I think we have another participation from the online.
I'd like to thank you for illustrating one of the problems I have been complaining about in the CITROPS working group, which is that a wrong ASPA signature is gonna wreak havoc on the other side of the world. And we are just lucky that it was CZNIC and not some weird network on the other side of the world, because if that happens, nobody's gonna reach them. So I'd like to ask you to kindly write a report about this to the CITROPS working group to wreak more havoc there. Thank you.
I will try. Thank you.
All right, next is online. Or, well, please
Audio
go ahead.
work? Yeah, sorry. Does my audio work?
Yes.
Okay. Yeah, thanks. I'm not sure I was actually in line before, Gerd, but apologies. Yeah, I've been thinking about this since Monday, and I'm happy, Andre, that you took the stage and made this presentation. Thanks a lot. I must admit, my initial thought was, okay, so RIPE NCC, obviously they botched this and they should not try playing ISPs, blah, blah, blah. Why do they have no default route? And so like people already mentioned, but in hindsight, I think it's this was a very good experiment. And also I would have run into exactly the same problem because we're in the same boat with these, you know, peers that provide, that I consider as a peer, but they provide like courtesy or how do you say, gratuitous transit to the world. And so, yeah, that's something I had thought about, but this made it more clear that we have to deal with this situation better. And so I think also what Rüdiger says, yeah, I think people are aware that IPv4 and IPv6 topologies are not congruent, but you have to be inclusive now. So you just simply have to include your IPv6 only transits in your ASPAs. So my question is, what do we collectively do with Hurricane? Huh? Do we tell them, okay, stop pretending to be our transit? You're not our transit, you're a peer. Stop announcing our routes. I think that would be the
Yes.
one.
I think I got the point. Yeah, let me answer
them all in the ASPAs, and then they.
Let me answer quickly. I don't think this is something specific to Hurricane Electric. It could be any misconfiguration or leak, and it would be basically sort of the same. And I would just say, if it was leak that would be dropping data or black holing them, you know, the worst thing by not validating here would be that we would send the packet to our upstream and it would be dropped further. Whereas when we validated, we just dropped it here, and that was basically the point of all my message. That either way, the packets would be dropped.
Okay, I think we have still time for another question.
Get long time IPv6 user. I think explaining this was a very valuable exercise, and I disagree with Job that it's the same as for ROA invalids, because it depends on where the topology you look and where you do the validation. So if your ISP had done the validation, they would have said this is a leak and just routed around it. With you being the food chain all the way down, doing the validation down there and not having a default route might not have been the best thing to do, but it pointed out the problem, so it was a useful exercise. What we would recommend to stop ASs that do have peerings is to basically accept from the upstream and filter on the peerings, so you don't get the leaks and you have a last resort, because not having connectivity is usually not what your customers expect you to.
That's exactly my idea.
And the Hurricane Electric thing is something that was very useful 20 years ago when we had very spotty V6 connectivity. And since at least 10 years, this free service with no SLAs attached, and thank you very much, is causing more harm than good.
Yeah, thank you.
All right, I think we have still a bit of time, so please go ahead.
Hello, Alawi, speaking with two hats. One of a former Anycast DNS cluster, and two with hobby network, which happens to provide internet to people. So first, Hurricane Electric really broke up my Anycast last time because there are free transit everywhere. It's just a crap. and you did the right thing, dropping the pass. Either an IS has Hashi as their upstream, and it's okay, they have the right to do so. But if it's just appearing, it's appearing, and it's a leak, and it has to be dropped. And second, I do filter Aspa on my hobby network, and nobody complains about anything because I'm not monohomed. So if someone leaks something, I can do something else and still have connectivity. So the issue is not Aspa, is being monohomed and having a pairing on transit, the alternate on pairing, sorry. So it's not an Aspa issue, it's a design issue.
All right, so.
Fair enough. I don't have reaction to this.
Unfortunately, I have to cut this now short, and thank you all for your participation. It was great. And yeah, so one thing I want to ask all of you, please rate the talks. It's important that we get feedback, so please rate the talks. And the second thing I want to announce is, yeah, there are still t-shirts apparently left. So if you're thinking maybe, yeah, I already had first t-shirt, maybe, what about second t-shirt? So yeah, then thank you all. Thank you, Andre, and enjoy the rest of RIPE.
Good morning. Please don't leave the room if you want to see how the general meeting ended up. So I have a voting report from the general meeting. I'm sure you are all interested in the results, so let's jump directly into them. First of all, the first resolution was the discharge of the executive board, and it was approved by supermajority, 91%, so approved easily. So the executive board is discharged with regards to its action as they appear from the annual report 2025 and financial report 2025. Resolution number 2. The general meeting adopts the RIPE NCC financial report 2022. Again, clear majority, 94%. The resolution was approved. And now I guess you are all interested, you know, if we will revoke the resolution that was passed almost 14 years ago in September 2012? And the answer is no. The option A1 by 51%. The difference in the votes is just 68, which is incredible. It's a good lesson, actually. I must say I learned a lot this week. And I understand the community is really split, and we can see it's roughly half and half. So it will be not easy to continue the discussion, but vox populi vox Dei. The option A was voted, and we will stay with flat fee model. And last but not least, the executive board elections. And we had 5 candidates for 3 seats, and you can see pictures of the winners on the screen: Raymond Yetten, Maria Hell, and Lars Johan Lehmann. So please let me thank the winners. And also, please let me thank the candidates, and namely Harald for his service for RIPE NCC. Thank you very much, Harald. Very last thank yous. Thanks, John Sweeting from Orange as the independent observer of the general meeting and voting results process. Thank you very much. And if you are interested, and I'm sure many of you are, about the details of the voting, please read the full voting report, which is going to be published soon, or it's published already. Any questions and comments? I'm sure there will be a lot of comments later, right? Anyway, the meeting is concluded. Thank you.
You could just sit here if you want, of course. It's absolutely an option. Hello, 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 hello. Good morning to you all. Could I ask you to take seats and end conversations as we move into the last plenary session of this rather wonderful RIPE 92. I'm Brian, and along with Max, we will be chairing this session. Before we move on to the first talk, just a couple of announcements, one of which is do please remember to rate the talks because it gives the PC all sorts of wonderful information about what you would all like for future meetings. Also, if you have recovered sufficiently from last night, there is a walk-up Arthur's Seat this afternoon, led by the local hosts Hilco Global, from 1:30 to 3:30. This time is averaged. It may take you longer or shorter, depending on your physical state. And you can meet at the registration desk to go on that walk. I highly recommend it. The view is awesome. So the other piece of administration that I need to do is the results of the PC elections. And once again, thank you to all of the people who volunteered, put themselves forward. It's hugely appreciated. And for those of you who were not successful, we really hope that you will volunteer and put yourselves forward in the future as well. So the two successful people were Max Stuckey and Paulius Eutychus. So congratulations to them. And yes, and again, thank you to everyone who put themselves forward for this. So let us move on to the talks. And Ginevra is definitely here. Yay. So we can bring up the slides there, please. Yay. So, a nice short title. But apparently post-quantum cryptography is quite a thing. So Ginevra, please tell us all about it. Thank you very much.
Hi everyone, I am Ginevra Fabrizio, and this is measuring the impact of post-quantum cryptography on federated identity management. The title is very long, so first of all, let's get started. What's this post-quantum cryptography? What's the quantum transition, and why should it bother us? So first of all, we refer to post-quantum cryptography as all the cryptographic algorithms that are designed to secure data against the threats posed by quantum computers. So right now, we do not have a cryptographically relevant quantum computer, but still there is the risk because, of course, a quantum computer is way more powerful than our actual computers. So what happens is that we need to transition to this post-quantum cryptography because quantum computers, when they will arrive, they will break our current encryption methods that are currently used, and they will put our communications at risk. For example, I think in the last couple of months, Google announced their Willow supercomputer, quantum computer. So yay. And so the thing is, who is right now already transitioning to post-quantum cryptography? Of course, big companies like Google, Apple, also Signal is already using encrypted post-quantum cryptography, and they are switching to quantum-safe alternatives. So, for example, Cloudflare already uses post-quantum cryptography for their communications. Also, Chromium is using it. Mozilla, of course. And in 2024, iMessage started using their own version of iMessage protected with post-quantum cryptography. Signal already in 2023. So the thing is it really that simple to just implement something and they just, okay, then that works? Of course, in these cases that I just mentioned, we just have a client and a server, or for example, just two people talking on the phone. So we have a relatively limited number of parties that are communicating and need to secure the communication. But the internet is huge and difficult to manage. So there are many more kind of infrastructures and protocols that need to be taken care of. So cellular networks, federations, IoT devices, and so much more. So in this talk, I will be focusing on identity federations and the relative protocols. In this case, I will be focusing on SAML and OpenID Connect, which uses OAuth 2.0. So what's an identity federation? So an identity federation generally allows organization to share identity user data. So for example, if I need to use, very personal case, Overleaf, and then it says, oh, you need to log in to Google, so I have to talk to Overleaf, then I have to talk to Google, and Google will then redirect me to their identity provider, and then I will go back to Overleaf. So typically, an example that here we will be taking, like there are many kind of federated architectures, but here we will be focusing on the hub and spoke architecture, which is shown on the right. So for example, here we can see this is called hub and spoke because we have a central hub that is managing the connections between the service provider. So in my case, I want to use Overleaf to write some papers. And the IDP, which is Google, and says, OK, then I have your identity, your user and password, and I will give it to Overleaf to share your data. So this is only one connection. So only one user authenticating through the identity, through an identity federation will do these steps. So the identity provider will sign a token that will be then sent through a secure connection to the hub. So it's one TLS connection. And then the hub will verify the token, sign it again, because the hub can act as both SP and both an IDP. So it will act as a service provider when it's talking to the identity provider, and it will act as an identity provider when it's talking to the service provider. So verifying, sign again, and then send it to the service provider. And this is, again, only one user doing one authentication. So imagine this for a lot of times. So what we wanted to do is to take a real-world example. So we wanted to use some real data from a real hub and spoke architecture and say, OK, what happens if they were to switch to post-quantum cryptography? So together with Surf, a Dutch identity provider, we gathered their data over the span of 25 days in the month of September, which we know is the start of the academic year. So many students just enroll. And it's basically the highest number of enrollment that they have. So what we gathered is their system load, all the successful authentication attempts, and the kind of authentication that took place. So we also had to differentiate between OpenID Connect and the SAML authentications, which they are different protocols, of course. So the number of signing and verification and overall cryptographic operation that happens are different. We also collected the HA proxy logs. We recorded all the HTTP requests, the TLS connection that they received, because of course for a TLS connection we have, on top of the SAML and OpenID Connect protocol, we also have the TLS operation, handshake and digital signatures. And we also recorded this whenever a SAML request or a SAML response was received, which they both mean two cryptographic operations. So what's the aim of all of this? So we want to estimate the overhead produced when we switch to PQC, when we take into consideration a slightly more complex scenario than just two parties talking to one another and just maybe for iMessage or a TLS connection. So cryptographic operations required by PQC is what we are interested in, because of course post-quantum cryptography is infamously known for having very big signatures and larger key size, and this means that they take up more memory, they take up more time to be processed, and also they affect bandwidth, they affect CPU load, they are computationally intense. And this will require additional resources to handle the increased load. So as also the provider said, that already as it stands, a whole authentication process can take anything from 1 second to several minutes with timeouts and whatnot. So if load and authentication time increase, what other resources are needed? So here you can see that we take the busiest day in September that we saw, and here we have the number of TLS connections, the number of validations, and the number of signatures. So SURF manages this hub and spoke federation through the central hub, as I showed it before, and they call it the SURF engine. What we will be focusing on, also for an operator standpoint, is the hub, because it's the one that handles the most operations. As we saw before, they have to handle the TLS connections, and they have to verify the token and then sign it again, because they act as both identity provider as service provider. So SURF Hub and Spoke Federation handles a bunch of ways to authenticate yourself, but what we will be taking into consideration is OpenID Connect, as I already said, and SAML. So what we want to put the highlight on is that we want to consider a worst case scenario. So of course we are taking Hub and Spoke because it's the one that takes the most operations. And also we took the day number, which had the highest number of HA proxy and HTTP requests. So what's the SAML authentication flow like in engine SURF? So first of all, this is their hub. So these are the operations that we will be concerned with. But as you can see, first step, the service provider sends the request to the hub. The hub acts as an IDP and says, oh, okay, then I need the IDP to check your identity. The IDP signs the SAML request that is received and sends it back to the hub. This is where we are interested, because then the hub performs a verification and then a signing operation and gets back to the service provider. So you can already see that here the hub is the one that is performing the most cryptographic operation. In total, we have 4, but we take these 2 into consideration. Okay, then this is the SAML one. This is a bit more complex. And the OpenID Connect authentication flow, it depends from operator to operator how this is implemented, but SURF decides to put a OpenID Connect gateway between their already existing SAML infrastructure. So they have basically a gateway that translates the OpenID Connect requests, which use Java Web Tokens, and then they get translated into a SAML XML response or message. So first of all, here these arrows indicate strictly OpenID Connect operations. The service provider talks to their gateway. The gateway has to sign, so we have already one operation of signing. Then it gets sent to their underlying SAML architecture. So they verify, send back to the IDP. IDP signs. This doesn't concern us for now. Then verify. The hub verifies, signs again, sends to the OpenID Connect gateway. The OpenID Connect gateway verifies, and then the OpenID Connect in the 8th step sends an OpenID Connect token with 3 signed Java Web Tokens. So here we have 3 signatures taking place, and they get sent back to the service provider. The 9th and 10th step happen whenever some more data is needed. They don't happen necessarily, they are part of the authentication process, but it's just to check the validity of the access, and they both performed a Java Web Token validation. So what's the takeaway of all of these? Is that these protocols are complex and they require a lot of cryptographic operations, and they also happen at different levels of the stack. So what did we do? To estimate the SURF engine load, we take into consideration 3 types of cryptographic operations. So signatures, signature validations, and key exchanges, which are the ones that which will be replaced by post-quantum cryptography, which is heavier, blah, blah, blah. So we considered the busiest period of the year and took the highest number of HTTP requests made. And for each HTTP request, we assigned 1 or more cryptographic operation that was shown previously in the process of either SAML or OpenID Connect. And as you can see here, so we have these huge HTTP request logs, and we say, okay, we know that IDP metadata we have in this day of September, we had around 5K requests. And this path means one SAML signing request, which uses RSA 4096 key, and so on. We do the same for all the rest of the path that we received. Also notice that for OpenID requests, OpenID connect requests, it might involve both SAML or Java Web Token signing, which are different, because Java Web Token, in their case, uses 2048 RSA, while SAML uses 4096. So we also had to take that into consideration. And the operation can be related to either Java Web Tokens or SAML. Which post-quantum cryptography algorithms did we select? They are quite a bunch, but we decided to take into consideration hybrid algorithms, which are the ones that are being used right now by Cloudflare and Google, and that they are the ones that are currently being tried for the transition, and also the final NIST candidates that have been chosen. So we selected a hybrid one that uses Kyber, Sphinx, which is a hash-based signature, Kyber, which is a key exchange mechanism. If this can help, this means signature, and this is a key exchange algorithm. Then we have another digital signature, crystals dilithium, Falcon, digital signature, and HQC, which is selected as of March 2025, and it is a CAM, a key exchange mechanism. So why we selected this? It's because we wanted to pick the most relevant algorithms, and we wanted to compare these PQC algorithms with their current infrastructure, so the traditional cryptographic that it's used right now, let's say. So why we chose these scenarios? So we decided to test lattices, signature, and hybrid key exchange mechanism. We wanted to try a lattice-based implementation and hybrid key exchange mechanism, which is the most, let's say, the easiest choice for an operator to go with, because in case you are using a hybrid combination, what you do, you use a traditional cryptographic algorithm, and on top of it, you put post-quantum cryptography. So you can, let's say, always roll back in case any of those post-quantum cryptography algorithms turn out unsafe, because this is the biggest problem for now. We have these post-quantum algorithms, but as long as we don't have a cryptographically relevant computer, we will not know if they are safe or not. So we wanted a lattice-based implementation because it's also what is more, their performance is very nice. Let's say they are also better than the ones that we are currently using. But every now and then, some paper that says, hey, it's not as safe as we thought, pops out. So people are still a bit, let's say, lattices are a choice. Then Sphinx and HQC, which are the only non-lattice-based implementation that is possible if we use NIST candidates. And then we also chose MLDSA and MLCAM, so pure lattice-based implementation. This is well described in our paper, but I will not be showing any plots about that because these two are the most relevant cases. So we wanted to show the differences between lattices and non-lattices implementations. So we ran some benchmarks. We ran 100 independent speed test algorithms performed with cryptographic calls continuously to a machine, and we ran these benchmarks using OpenSSL together with Open Quantum Safe. For digital signatures, we have the best performance achieved by MLDSA and Falcon, and the worst performance is from Sphinx, both the fast and simple implementation. While for key exchange mechanism, we have MLCAM, which highly outperforms traditional key exchange methods that are now used, and the worst performance is by HQC, which is the one that has been newly appointed as of March 2025. So how do we compare the performances? We compare the CPU load of each possible implementation, so of the two PQC scenarios that we want to take into examination, and the traditional one, of course. And here you can see the actual implementation that they have. We had to separate between the federated identity management operations and the TLS ones, because they happen at different layers of the stack and they use different key sizes. So a maximum load, here we show a CPU load, which expresses the CPU time that is used to perform a set of cryptographic operation, and 100% means that a single core is being saturated by cryptographic operations, which means that the user has to wait for their authentication to happen. And we also want to show the desired over-provisioning preferred by SURF, by the operator. They said that they want to at least have a 60% load of over-provisioning to ease all the operations. And in case the load is exceeded, so in our case 100%, it means that the queue is filling up. SURF would rather not to go over 60%. So we compare their traditional actual implementation, and we can see that the maximum load that they achieve is 12%, with an average load of 3 and almost 4% load. And the first PQC scenario, which is hybrid key exchange mechanism, which is the one used right now by Cloudflare and Chromium, and purely PQC lattices digital signature. And we have that the maximum load is actually lower than the one that they are currently used, and the average one too. And it's more balanced between key exchange and signing. So the first PQC scenario that we are taking into consideration has faster signing and verification time, so this is very nice for operators, and this leads to less computational load compared to the actual implementation that SURF is using. The second scenario, which is also please note the difference in scale, this is the same. We are still taking into consideration the traditional implementation. We just hinded up the scale because, as we can see, using Sphinx and HQC, which are, again, the only non-lattice-based signature and key exchange mechanism that NIST is appointing as a future use, the maximum load is 3 times higher than 100%, so they are taking 3 times the CPU load, and the average load is a fully loaded CPU core. And we have more than 3 seconds of core load for a peak of operations. So what does this mean? It means that we were to use non-lattice implementation that are standardized by NIST. The PQC scenario requires up to 4 times the current load that is being taken up by SURF. So as we mentioned, Sphinx and HQC performance is very problematic because it uses more than 4 times the computational resources owned by SURF. And MLDSA and the hybrid key exchange mechanism perform slightly better than the already existing cryptographic standards. So if lattices are proven to remain quantum safe, then migrating to them is the best choice if they are safe. So what can we gather up from all of this? We can say that lattices and other implementations, they have the potential to outperform our currently used standards, but relying only on lattice-based schemes is not a safe bet, because if lattices turn out to be unsafe in the future, or when we will have a cryptographically relevant quantum computer, this is a mess. And also what we would like to point out is that existing protocols, so for example, current SAML standards, they require the use of RSA 2048-bit signatures, but leaves other signatures as optional or up to the implementer. So this standard will not hold up in the post-quantum era and will have to be revised to accommodate post-quantum resilience. This paper was submitted at TMA last year. And yeah, thanks for your attention. If you have any questions, I'm here.
Thank you, Ginevra. I see we have already a question here.
Hi, Yaroslav Rosomacho, Zscaler. First of all, thank you for the presentation. I find a little bit confusing that a key exchange and digital signatures are kind of grouped together in one concern because they operate at different layers of the stack, and the digital signatures in particular, in my experience, are much more complex compared to key exchange. So maybe a piece of feedback for the future would be great to separate them. And secondly, I see that you measured, that you used Open Quantum Safe for measurements. Did you have a chance to try actually production libraries such as OpenSSL, AWSLC, Boring SSL?
Not yet, but we would like to try them out.
Great. Thanks.
Thanks.
I see. Question?
Hi, Shane Kerr, IBM. This is amazing. I love everything post-quantum, even though I don't understand any of it. So
it's okay, me neither.
You highlighted the concern about the lattice collection techniques. What are cryptographers first thinking? Is there a concern among the professionals that this is actually a potential vulnerability?
So this is a very interesting question because I'll be honest, I was first year PhD and then we were doing this, and after like 2 months came out this paper, very mathematically dense paper that was saying, hey, lattices are like some order of magnitude less safe than what we expected. And I'll be honest, this was 2 years ago, and there are so little people that are expert in that field that like I did not have any more updates on that, but I assume they are probably still looking into that because it was this very mathy paper, very lengthy paper that was basically debunking the safety of lattices. But I am 100% sure people are still looking into that because the experts in that field are not enough. I also looked at that and I was like, okay, this is way out of my capabilities. But I think the claims are kind of, we should still not rely on only one kind of mathematical problem just for safety. And yeah, and also another paper I think came out a while ago that also said that lattices were a bit not as safe as we thought, but it's still like, let's say if we thought that they were this safe, this paper are like, no, they are actually this safe. So it's just a matter of time.
That's definitely a concern because they're so new, right?
Yeah, exactly.
Yeah.
Okay, I don't see anyone else in the queuing. Do we have anyone online? Well, then thank you, Ginevra. Thank you very much.
Thank you.
So next up, we have Alexander Mannel talking about Hilby, visualization for prefixes, a tool that he wrote.
Okay, yeah. Hi, everyone. I'm Alex, and I'm going to talk about Hilby, or Hilbert Interactive Prefix Plots, but what that means exactly, we will get to in a minute. You as operators probably have a lot of information and data that can give you insights into optimizing your workflows or deployment or make them more resilient. And a lot of that information, due to the nature of what we do here, will be related to IP addresses or prefixes, so sets of IP addresses. And some examples for that may be flow data. So you have questions like, hey, which address range receives the most traffic, is the most important for us? Or on the importance of addresses, how many domains resolve to any specific one IP address in my network? So is this IP address for some reason more important? Or just BGP announcements. So what prefixes do others observe of my network? And I'm going to stick with the last example of that. So we're going to talk about, I will use, because as a researcher, I do not have the internal operator data, but I do have the great write risk data. So I can talk about that last third case of what and how much address space does my AS currently announce according to write risk. Now, if I want to investigate this, the first thing I do is I go to write risk, so I got some data, and then I have to visualize it in some intuitive way so I can derive meaning from it because I work visually. And so how do we do that? Well, option one, maybe a table. Very detailed, but does not provide a great overview of the data. And depending on how rich you are, this list is also going to become quite long. So maybe we want to have another option, like a pie plot. This is great for overview, but we're losing kind of some of the details here, some of the maybe interesting parts, because it is getting averaged out on this visualization. And maybe someone already has an idea which AS data I used for this. And people have come up with other ideas, mainly a thing called Hilbert curves. I believe the actual original use case of this, or the first use case that I know of, is the XKCD 195, where he drew the original allocations in classful routing and also the allocations to the different rears to create what he called a map of the internet. The AND group at ISI has also done this for their internet census data and is regularly publishing sort of these images of the IP address space. And as a shameless plug, we also did that a couple of months ago for a paper talking about network telescopes. So why do people like Hilbert curves for this type of visualization? The answer is, first of all, Hilbert curves are a way, or are called space filling, or a type of space filling curve. And they are called that way because they help us plot one-dimensional data, like the IP address space. So every IP just has a predecessor and a successor, into two-dimensional space by essentially providing a coordinate to that value. There's a bunch of those, but the Hilbert curve has this great additional property that it maintains the locality of the original data very well. And what that means in IP address terms and not mathy terms is if you have two prefixes or three prefixes, in this case, for example, on the right, 1/8, its two neighbors, so 0/8 and 2/8, are physically right beside it. And this also holds for their sub-prefixes. So the 4/10s that are contained in 1/8 are all within the area of 1/8. And these neighboring, this neighboring property, so for 192/10, holds even across the borders of bigger prefixes. So you can see in this case, 2/10 and 1128/10 are the neighbors. Okay, so we've established we want visualizations of IP address related data to help us understand things. Hilbert curves are a way to do this. But we do lack some tooling to create interactive and scalable plots. There is some older tooling for this, but it creates static images, and I wanted to have something that I can dig through. So this is where Hilby comes in, or Hilbert Interactive Prefix Plots. It is a small React framework that abstracts away all the complexity of the math behind it, of the user controls. So you have zooming and dragging controls, also for mobile. You have interactive expanding of subnets. This is something I'm going to show in a minute. You have full CSS and content control over each subnet. So you can just tell any like color or text color or background image that you want to have a specific prefix to show. You could even do a moving rainbow marquee tag if that would be of interest to you for whatever reason. It is also IPv6 capable, and in IPv6 the aggregation is actually much more important. And since it's running in the browser, you can do on-demand data fetching. So you don't need to pre-build these images. You can build them on the fly. You can change colors, whatever. And I have, because I don't want to challenge the live demo gremlins, a little video of this, what I called expanding subnets. And so this is the demo page. I'll have a QR code up in a minute. It's not running yet. OK. And we can see, OK, this is the full address space. And we can dynamically move in and sort of split up specific areas into higher detail if we were interested in this. So this is all announcements from the AWS or the Amazon AS of 60 and 509. And we can see we can go to completely different parts of the address space and sort of dig in all the way down to the individual /24. And if we want to go out and sort of understand the macro image again, we can just do that as well. Okay, so back to my slides because I'm running out of time. So how does that work implementation side for you if you wanted to do this? It's very simple. Hilby wants a callback function from you. It'll ask for a prefix, the one that the user is looking at, and it will give you a config object. And in this config object, you can just tell Hilby, hey, this is the color I want, this is the background color I want, this is all the sorts of things that I want to see. And Hilby will just apply that to the image. So this is all the data, or you as a data user would have to implement. Okay, so if that made you interested at all, the source code is available. It is all on GitHub, it is open source, and there's also a playground where you can upload your own CSV as long as it looks IP address value, and sort of explore it a bit in Hilby. I've tried to get that as general as possible. If your data breaks the playground for some reason, please write me a GitHub issue and show me the data that did that. Okay, thanks.
So, thank you very much. Do we have any questions? No, everyone just thinks it's cool because it's cool. Thank you very much.
Thank you. Brian?
Sorry. Sorry,
yeah.
there wasn't. Yes, sorry.
Yes, there are a few presentations that make me angry. I hadn't thought of that. I love this. Beautiful work. Thank you.
Thank you.
Cool. Excellent. Thank you very much. And now, to move from that to apparently a whole bunch of infinite monkeys. But yes, so Warren is going to talk to us about bit squatting, cosmic rays, and monkeys, I believe.
Indeed.
So please, go ahead.
And Warren has a request for the program committee. Next time, please don't put me after a really good presentation, because I'm going to look real dumb. So, bit squatting, or the infinite monkeys theorem. This is an update from some work done in 2011 and 2018. But presumably everybody's heard an infinite number of monkeys hitting keys at random will eventually produce the work of Shakespeare. Is this something like this actually true? So a little bit of background. If you enter something like a domain name, somewhere in RAM, it's stored like this. If a bit were to flip from a 0 to a 1 or a 1 to a 0, potentially it ends up in another character that's also a valid DNS name. Different view of that. But surely stuff like this doesn't happen, right? We believe that computers are largely deterministic. Well, turns out it does actually happen, not infrequently. One of the most common causes of this is radiation. So a common thing is cosmic rays, or if you are using leaded solder, lead used to contain little bits of radioactive material. One of the best known cases is from around 1974. Computers were becoming a lot more common, and Intel decided that they needed a lot more of the ceramic packaging material. So they built a factory for this on the Green River in Colorado, and it was downriver from an old uranium mine. And the water that they used was contaminated with little bits of uranium and thorium, and these would create alpha particles, which would cause RAM issues. There are also more real-world consequences. This was a flight from Singapore to Perth, and a bit flipped in the air data inertial reference unit, and the bit that said whether the data is the angle of attack or the altitude was flipped, and the flight computer panicked, pitched the plane down at almost 9 degrees, and 53 people ended up hospitalized. 14 of them had to be airlifted to hospitals. But why would you care here? Presumably you aren't planes. Well, as I say, this is some work from earlier, and I decided to have a look if there are still these types of events happening. So I wrote a small thing that would let me enter a domain name and would give me all of the valid bit flips of that were also domain names. I then went off and registered some of these. This was originally presented at ICANN, so I used some of the ICANN names, some large US financials, and some other large companies. FBKDN is a single bit flip from FBCDN. The rest of them you can probably figure out fairly easily. So then I set up a web server to try and capture if anybody was reaching these names. And I set up capture what I'm calling expanded names and SNI information and cookies and URLs. And probably everybody in the audience is now thinking, meh, probably everything he's seen was simply just people doing typos on keyboards. That's a valid concern, but I tried to minimize that by choosing sort of domain names or things which are far away from each other on the keyboard. That's a minor mitigation. I'm also trying to capture what I'm calling expanded names. It's entirely possible that somebody would type in microsont.com, but it's less likely that they would actually accidentally type in msh.b.tlu.deal.delivery.mp.microsont.com. I also tried to do more API or system names. So, this is an API endpoint. Still possible people might typo it, but, these are generally handed out in the HTML or when you're following a URL. I also was collecting SNI names. A quick refresher. In a TLS connection, your browser or whatever says what site it would like to connect to. And so if I have microsont.com and I am getting hits for microsoft.com, it's clear that that was the intended name. Somebody didn't typo it. And also, full URLs. It's unlikely that anybody would have typed this in. Possible, but this was clearly a link on a page. So, as I say, I set up a web server and started collecting stats. As you can see, there's a bump in, mid-May. I added some more names to it at that point. That explains that bump. And I was getting a bunch of hits. But as you know, if you put a domain name on the internet, you get a bunch of WordPress scrapers and those sorts of things, people banging on the door. So I tried to filter out as many of those as I could. And I ended up with some stats. And these seem to be people who are really getting bit flips and now hitting my server. What's interesting, and more research is needed here, is there's this thing called the estimated planetary K-index. And that is basically a graph or number of the amount of cosmic rays hitting the Earth at any given time. And, more stats needed, but it kind of feels like there's a correlation here. But why is this interesting? Well, some of the things I was doing is collecting what I'm calling expanded names. Over a 1 or 2 week period, I don't actually remember how long this is, I got at least 719 people trying to reach teredo.ipv6.microsoft.com. If I decided to set up a Teredo endpoint there, people would proxy their traffic for me. Sounds like a good idea. It made me a little sad. Then I started logging SNI names. This is kind of interesting. That doesn't really tell you much, right? I can't do anything useful with this. I don't have certs for any of these for obvious reasons. But it still made me a little bit sad. Then I started logging login URLs. So these are places where, like in the top example, somebody's clearly trying to log into their Bank of America site. This URL was embedded somewhere on the login page, and somebody came along and tried to connect to me. I have a cert for Bank of America, and so I could just serve them that and provide a phishing page. I'm not really doing anything wrong, right? People are coming to me and trying to reach me. I could connect these. So then there's things like JavaScript. This is a tiny selection. I got thousands and thousands of people trying to reach something.js. And what I think would likely happen, depends on exactly where the bit flip happened. Often, if I were to serve them JavaScript, it would be running in the same web origin as the original name. So I could just ship them some JavaScript that's like, here you go, it's in your same web origin. I can have the cookies, please. Ship them over here. Or any other interesting JavaScript thing, because most of this will happen in the correct web origin. That made me more sad. Then there are things like executables. If you're trying to download the .NET installer and you go along and you get an executable, Even if you're running Windows and Windows Defender says this is probably sketchy, you clearly downloaded it from Microsoft. It came off their page. You followed the link. You just happened to fetch it from somewhere else. That's another one that may be even more sad. Now we get onto cookies. I had many thousands of cookies collected, but this is people are just trying to connect to a site. There's a bit flip, and they send me their cookie. This one is somebody apparently trying to pay the rent for their apartment. This one is somebody trying to reach Atlanta Specialized Care, which is their health provider. I could just collect these cookies and, pretend to be them, play them back, etc. This was, I believe, over one day. I just collected things that look like, cookies that are authentication or login tokens. I could just collect all of those. I know where the person's trying to go. I have their auth cookie. I can just play that back. But we all believe TLS should save us from these sorts of things, right? Like, if it's a TLS site, people won't connect. Sadly, that's not always true. Here you can see the SNI is Microsoft, so the browser believes it's trying to connect to Microsoft. I don't have a cert for Microsoft, so I just sent them one of my Microsont ones or similar. But they continued the connection because they came back, and over the TLS connection, they handed me their cookie. So depends on exactly where in the stack the bit flip happens. TLS doesn't always save you, which made me more scared. So why did I redo this? Well, there is going to be a new round of new GTLDs coming real soon. I thought, wouldn't it be sad if somebody were to register a bit flip of a very well-known TLD? Maybe in the ICANN process, we should have a sort of rule that says you can't register a bit flip for an existing TLD. So I started writing that up, and I was like, before I propose that, let me just make sure this doesn't already happen a bunch, because otherwise I'll look dumb. Here are all single bit flips of existing TLDs to other existing TLDs, where it's a single bit flip from one to the other. There are about 60 of them that are one bit flip away. One of them stood out, happens to be if a bit flips in .com, you end up at .bomb. So there's another big well-known TLD, single bit flip, people end up in the wrong place. I don't know what we do about that. One mitigating thing is I actually spoke to nick.br and explained this to them, and they're like, maybe we shouldn't allow any registrations in .bomb, so good on them. But, well, what's the conclusion? Computers suck sometimes, the internet sucks. I don't know what we can do to mitigate this. Like, ECC RAM would help, but clearly you're not going to have ECC RAM in your phone anytime soon, so oh well. Do we have question time?
We don't have any time for questions for this one. So next up, we have Andrew McConaughey giving us the report from the Code of Conduct team.
I apologize in advance. I don't have any cats in my slides. My name is Andrew McConaughey. I'm on the Code of Conduct team, and I'll be talking about the Code of Conduct report that happens at the end of every RIPE meeting. There we go. So since RIPE 91, oh, thank you. I didn't know how to do that. I appreciate that. Yeah, that's good. Okay. So since RIPE 91, we had one issue at RIPE 91 that was resolved. We concluded it was a violation and issued a warning. We were also contacted about something that happened at RIPE 91, after RIPE 91, and the reporter decided not to move forward. So at RIPE 92, I didn't have time to update this slide, actually, because about an hour ago we received an incident. So up to about an hour ago, we were at zero open cases, 0 RIPE 92 reports. Now we're at 1. So we have one open case, and we're still triaging it, and that's all I'll say about that. This is the standard slide about how to contact the Code of Conduct team. We always want to hear from people. If you're not sure whether you should contact us, we would love to hear from you. Please do. It doesn't have to become a report. You can just stop any one of us at any time and talk with us pretty much about anything, even if you're just feeling uncomfortable about something. There is a form. You can write the email address. You can write any one of us directly. You can also say, when you contact any one of us, you can say, I would only like to deal with you, or I'd only like to deal with you, you know, or and a couple other people, or I really don't want to have to deal with this person on the Code of Conduct team. We try to be flexible as much as possible in the interest of the reporter. So if you have any questions about feeling uneasy or anything happens at a RIPE meeting or in a RIPE context, please contact us. Last October, we conducted the first RIPE Code of Conduct survey, and I've got 2 slides to kind of just give some high-level feedback on that survey. If you want to dive deeper into this and you're really interested in the output on this, there's a RIPE Labs article, and I'll give the link to that on the next slide. But first, the purpose of the survey, we had this question, right? It was like, we don't get that many reports. And so we had this question of, are all RIPE attendees angels, or are people just not reporting to us for various reasons, like because they're scared to report, or they don't know how to report, or whatever? So these were our 2 main research questions, like how safe do community members feel at RIPE meetings, and how likely are community members to report breaches of the Code of Conduct, right? And kind of a tertiary question related to those was, have you ever seen or experienced something at a RIPE meeting that you didn't report? We were interested in that as well. It was open for all of October 2025. It was 5 short questions, completely anonymous. Yeah, and we've decided as well, we want to make this a regular thing. We're not quite sure whether we would do it every 2 or every 3 years. We're still thinking about that. But the idea is that for the purposes of collecting longitudinal data, and just, we want to make this a regular thing. So here's some of the feedback we received, or well, the high level stuff at least. And again, if you're interested in diving into this more, I do recommend the RIPE Labs article, not just because I'm the author. I think that the best thing to come out of the survey was that we received 93 responses. That's a pretty high response rate, I think. I wasn't really expecting to receive that many responses, but glad we did. Predominantly male, of course, because I think that's representative of the community itself. As far as how safe do people feel at RIPE meetings, the median response was 9 out of 10. It was higher for men than for women and for those who chose not to report their gender. But still, I don't think we could do better than 9 out of 10, right? So that was pretty good. The second question is more mixed, right? Like, would you report misconduct to the COC? 63% said yes, for sure. 28% were a maybe, and 9% were no. And we had another question, which there wasn't really room on the slide for this, but it's more like, if you've ever experienced something at a meeting, did you report it or not? And we drill into that more in the article. I think that 28% is somewhat concerning, but again, maybe could be for a lot of different reasons. And again, as I stated, there were different differences between male, female, and people who didn't report their gender. In general, men just feel safer and are more likely to report incidents. Like, that's a very easy statement. That's a very easy statement to make based on the data we received. Team updates. We had one member leave us. Big thanks to Samane, who was with us for, I think, close to a term. Thanks a lot, Samane. We've also been doing some outreach. We presented at the RIPE Fellowship group call a few months ago. We are working on an FAQ. I think we said at RIPE 91, we were still working on an FAQ. We still are. We got sidetracked with the survey and whatnot. We're also working on publishing a transparency report as RIPE documents. So right now, the only real artifact we create are these presentations that's public. So we need to get better about recording the kind of recording and archiving the kind of information that we're producing about how many incidents we receive at each RIPE meeting, that kind of stuff. Like basically turning these presentations into something more that's, I guess, appreciative is like a historical artifact. And also so that, again, we can, capture data for longitudinal purposes and for measuring and whatnot, and just to be more transparent. So we're working on turning these presentations that are transparency reports into actual RIPE documents for that purpose. This is us. You've probably seen our faces a bunch this week. Our faces seem to be everywhere, which is cool. We did get some reports where people are like, why are your faces in the toilets? And we were like, yeah, probably next time we're going to work on not having our faces on the posters in the toilets. But we do want to have some kind of notification in the toilet so that people just know that we're out there and that we could be contacted. So we're going to continue to have posters everywhere at RIPE meetings, but they'll be our faces won't be in the toilets anymore. And that's it. I don't know if we have time for questions, but I'd be happy to take some.
Well, thank you very much. We are tight on time, but if there are two very quick questions or comments or otherwise, I think, Sander, you were there first.
Hi, Sander Stefan, and I hope I'm speaking on behalf of all of us when I say thank you very much for doing this very difficult and important work to make this community a better place, to the whole team.
Oh. Thank you. Thank you very much, Sander.
Sachin Romain, I specifically wanted to thank you for acknowledging earlier in the presentation how hard it is sometimes to report, and that you really want to make it as easy as possible. I've seen events that take no reports and everything is great, everyone was nice. So it's so good that you're acknowledging and trying to help people to actually report something if it feels off. You are doing excellent work. This is really hard work. I've done it in other communities. Thank you very much.
Thank you very much, Sasha.
Okay, cool. Thank you very much. And now, for the presentation you've all been waiting for, how it all worked, how the bits for our little traveling circus got to all the right places, and the video and all of the other fun things. So, Rob, please give us the RIPE 92 technical report.
Thank you. This week, there was no need to look at the RIPE NCC status page to find out how our week was going. The people in this photo were your most reliable uptime indicators. If these faces were smiling, everything was running smoothly. If you saw one of these people in this photo running through the hallway, something was probably on fire. So my name is Rob. I'm part of the RIPE 92 technical team. And I would like to share with you a summary, basically, of how this week went from our perspective. This week actually started very early for us because getting our shipment through customs was proved to be an interesting challenge. For each item we shipped, the UK Customs Office required a lot of information from us, and that combined with the fact that we are shipping over 1,600 items to each meeting, proved to be a lot of extra work. So after filling in these customs forms, already one day later, we received our first rejection. Be more specific and please count each individual item. So we went to our storage, we counted all our network cables, resubmitted it, and after a couple more tries, we got the approval. So our shipment was on the way. So what are we actually sending here? Well, like I said, a lot of network cables, some Supermicro servers, a lot of access points. Wait, I see that UK Customs Office rejected this slide. Let me try again. We brought exactly
exactly 266 Ethernet cables ranging from 1 to 30 meters, and a bunch of other stuff. And specifically for this meeting, also these EU, UK power converters, which we ran out of during the week. And as you can see by the picture, we haven't been to the UK for a while, looking at the logo there. So we had a short setup weekend. Our truck arrived on Friday. We started the setup on Saturday. This 1 day shorter as usual, mostly made possible by the fact that we have these new bigger access points that saved us a lot of time on taping them down, mapping them out, planning. But also, we have to say the support from the venue IT staff was really amazing. They're very professional, responsive. It's great. A little bit about our meeting infrastructure. This is the logical topology of our meeting network. All the routers that we run are virtualized onto very small Supermicro ESX hosts. And for this meeting, CommsWorld kindly provided us with the connectivity. The venue kindly allowed us to place our equipment in their patch rooms, which were very neatly organized until we came along. Pictured on the right, you can also see this little switch with 6 Ethernet cables in it, which is feeding the 6 larger campus E7 access points in the main and side room. These are our 2 hypervisors. They run about 25 VMs on them, and they are mostly deployed using Ansible. One of the fun things about visiting these different venues in our job is that sometimes you come across these relics from the past. So in this case, it was surprising to find that some of the wall outlets, even here, and in these punch-down blocks from the 70s, they work fine. For the meeting network, we like using as much open source technology as possible, and these are some examples of that. I don't know what this is exactly, but maybe we'll hear a presentation about it next meeting, hopefully at least within less than 13 months. Moving on, this is a map of our access points placed on the current floor that we are at. Yeah, as I said, we're using significantly less access points than in previous meetings. We first introduced these at RIPE 91 in one of the rooms, and they performed really well, so we bought a couple more. We also bought the official stands that go with them, so we no longer have to tape them to a camera tripod like last meeting, which is an improvement. Also for this meeting, they again performed quite well. During a busy session in the main room, they would get like 200 device associations while still getting acceptable speeds. Also, we used in the other rooms a couple of the smaller access points. Don't rule them out yet, because this tiny one at the lunch area next to a trash can held the record for most device associations at lunch, which was 275. But we also had some problems. So on Monday, we started getting reports from a small group of people about some of the IPv6 connections being dropped on the RIPE MTG network only. After investigating, we saw some similar reports on like the Ubiquity forum, but they were not exactly the same as what we were experiencing. The advice was generally reboot your access points, and so we started doing that on Tuesday, rebooting them regularly. We also tried a bunch of other things to fix. Yesterday, we also tracked down a problem with one of our switches, which we removed this morning. The difficult thing with this is, out of hundreds of attendees, it happens to a handful, and then only a handful of that report these issues to us. But because we're really interested in troubleshooting these issues and trying to fix them, small public service announcement. Are you experiencing any connectivity problems? Please find us at the IT help desk or email us. And then, yeah, see it, say it. We'll try and sort it, at least. Very fast about the presentation system. This is what it looks like on paper. It looks quite neat and tidy here. Again, in real life, maybe not so much. Each side room, or each room, has two Mac Minis connected to an HDMI matrix switcher. The slides are uploaded through our website. They get rsync to the tech desk at the back every 5 minutes. So back at the tech desk, we prepare everything for the next presentation, and then at the right moment, we just switch the preset. On the previous slide, you might have noticed these small keyboards also. We use them because we have very limited room usually in the back. Yeah, they're quite convenient, unless maybe you haven't had your coffee yet and you're trying to scroll through the intermission slides. Anyway. We prefer sitting close to the AV team usually. That didn't happen this time. They're up the top there. But it really helps to fix these lighting or sound issues quickly. So for example, on Monday, the audience lighting failed. If you look very closely, you can see my colleague Andre, a shade of my colleague Andre, asking a question during the plenary, but especially for the online audience, it was really difficult to see. So we attempted to communicate this through walkie-talkie to the AV people for several sessions, but later we discovered the tech desk and the AV team radios had been on separate channels the entire time. It was fixed on Tuesday, though, together with the lighting, which by then was kind of unfortunate for Andre because he no longer had that cloak of shadows over him when he tried to climb on stage, fixing a cable during our CEO's presentation. A new feature I want to point out is the ability to upload this private version of your slides. It was a really highly requested feature for presenters, so that some people would like to present with presenter notes, and they did not want them visibly public on the website. So with this feature, you get to upload your slides. So the tech team receives your presentation that we show on the lectern here, and on the website it will only have the PDF without the presenter notes. So big thanks to our web services team for working on this. Then lastly, some statistics. On this slide, I would have loved showing you the statistics of the IPv6 versus IPv4 traffic. I'm sorry to say we still don't have these. It's been on our wish list for a long time. Yeah, we only get so much time between meetings, and we have our regular jobs also at the RIPE NCC. Then some Wi-Fi statistics. So here you can see the first activity is the 2 days during our setup weekend, and then gradually it gets busier. I don't have this morning statistics here yet. And finally, some coffee consumption seems to be down compared to previous meetings, but still the barista pulled like almost 1,000 shots per espresso per day, which is still impressive. And lastly, I would like to give a special thanks to Meetecho for our help with the remote presentation. 2 of them are in the back. The others are remote. Thank you. Again, also very big thanks to our amazing stenographers, again, who did a great job again. And then comes World for providing us with connectivity and the venue, which has been really great. So, thank you. Any questions?
Do we have? Oh, I see one there.
Blake Willis, happy community member. Thanks very much. Awesome conference as usual. Just a quick one. Please don't take this as a critique or a complaint or anything like that, but I'm just curious why we're still using bind 9 as a resolver. I mean, I imagine there's probably a good reason for that.
Can I answer to that? Hello.
My colleague Andre will answer.
So the reason why we ended up in bind, I actually tell this like in RIPE 98, the one in Krakow. Basically, is the only DNS resolver out there that can do at the same time DNS over HTTPS, DNS over TLS, DNS over UDP54. People still use this as well.
And donuts.
And at the same time, it can do DNS 6.4, but it can also do DNS 6.4 only for particular client subnets. We don't want to do DNS 6.4 everywhere, but only somewhere. And all this combination of features, we used to use not resolver, which was supporting it. Unfortunately, I found a race condition there, which makes some problem that we had in, where was it? In Italy, in Rome, that you said GitHub.com is blocked. And it was actually an issue in not resolver that I happened to reproduce. I reported it. It's sitting there. It's a concurrency issue that is super hard to trace down. The person that was working in it decided to leave the company because of this, I guess. So, so until it's resolved, the Bind9, and Bind9 is still alive. It's developed. People are developing it. Are here in this room probably. So it's nothing wrong with it.
Great, thanks. That's a good reason.
All right.
I don't see any other question. Do we have anything online? So, well, thank you very much.
Thank you very much.
So this concludes the basically the session for us, and I will hand it over to Miriam for the closing.
Hello, everyone. It's always exciting closing the week. It's a busy week, and it's great to see so many of you still here. Let's show you some statistics as well. Click, click. Is it showing anything? Ah, there we go. This was almost our biggest meeting. Total check-ins, both online and on-site, are like just close to 1,000. We had one meeting that was slightly bigger. There was the one in Rotterdam, the last one we had in Rotterdam, where we were just above 1,000. But it's also great to see so many newcomers here. You see the numbers there on the slide, and the countries here. We had people from 55 countries. The top 5, of course, the usual, kind of local crowd is here, obviously, and then people from, Germany, Netherlands, the US, France, like the larger countries, but then also many other countries were here represented. Thank you, Edinburgh, for having us, for even having the Law Provost come and welcome us at the opening plenary. Beautiful city. I hope some of you had time to explore or maybe stay around for a nice weekend. Also, I want to recognize the local hubs that were connected to our meetings. 3 of them throughout the week. They sent us some pictures. They were really active during the week and had a good time there, and then in Turkey, in Poland, and in Bulgaria. And again, I have to put them on here on the slide. Of course, a big thanks to the Code of Conduct team for providing the safety net for us here at the meeting. And also for providing this great report we just heard. Another big thanks to the working group chairs who are handling the content and the engagements of the different working groups. Here you see the slides, you see the pictures here of all the working groups, and as usual we're saying goodbye to some of the working groups. Some of them have been around for a long time. Thank you very much. If you can come up here. I don't know if you're still here, Leo, Moritz, Peter, and Yulf. I know Nina isn't here anymore. She had to run to the airport, but I gave her a little present when she ran out. I don't know if any of the others are still here. Leo, don't be shy, come up. Thank you very much for being a co-chair of the Address Policy Working Group for a long time. And there's Yulf coming also. He's been co-chairing the Cooperation Working Group for a long time. And I don't know if Peter is still here. And Moritz? Nope. Okay. Well, then, thank you. You can choose which color you want.
Thank you very much.
So you get the white one. Thank you. Thank you so much. You want to have a picture? Have a picture. Thank you.
Picture of me with the no pictures.
Oh, I'm sorry. We'll blur you in the photograph. And then we, of course, also have some incoming working group chairs and one returning, like thanks to David for keeping, for running for another term in the database working group. We have a new working group chair in IoT, Ramona. Unfortunately, she couldn't be here this week, but she got a good support from the group. I'm looking forward to working with her and Anna-Maria in the IoT working group. And we have Mark van der Waal, a new DNS working group chair, who's here, and then Leslie Noble for AP Address Policy Working Group. So we'll hear more from them before the next meeting, I'm sure. Also, the PC, you've seen them around during the week, sharing the sessions. These are the faces of the program committee members who are responsible for the plenary. This meeting, thank you very much for putting together a good program. I heard good feedback about the content. And please also, fill in the survey and let us know what you thought about it and rate the talks. There's one PC member who's leaving, who decided not to run again. It's Kevin. Kevin, are you still here? Don't see him. Thank you, Kevin. He's still going to be around, but he has a lot of other engagements and decided to not spread his energy too thin, so he's going to step down. And then you already heard the new PC members. Max has been re-elected, and we have Julius as a new PC member, and we're also adding Michael as the representative from the Central Asia region. So these are the new team members for the next RIPE meeting. And of course, a big thank you again to the meeting organizing team, especially Hafsa, Kajal down there. They look very relaxed on the photograph, but I've seen them running around a lot. And I mean, this was an amazing effort to put this meeting together in this venue. So thank you very much. And then also a big thanks to all the other RIPE NCC staff who are here, either to support us or also to engage with the members and the community in various forms. And last but not least, of course, a big thanks again to all the sponsors who contributed to this meeting. And I would especially like to thank the host, and maybe have somebody come up here from the local host. And again, please rate the talk so we have your feedback. And I also send a mail afterwards with a lot of links that you can use there. And then also here's a QR code for the feedback. So if you want to scan that quickly, so if you provide us some feedback while you still have it fresh in your mind. Is there a comment before I move on, please?
Hello, hello. Robert Kistaki, RIPE community member. I think we also need to thank the local weather gods. I feel deceived about the Scottish weather now.
Especially today, it's really nice out there. Yes. And it seems to have rained only when I was inside, so it was always wet when I came out, but it was sunny, it was great. Yes, so I hope you all scanned the code in the meantime. And now, yes, quick.
Just want to mention that yesterday there was a very successful AI BOF, and I heard there are plans to do another one at the next RIPE meeting.
That's up to the PC to decide, I guess. But yeah, thanks for mentioning that. And then we're coming to the part where we're actually welcoming the local host and telling you a little bit about the next meeting. Unfortunately, the local host, which is actually the Bulgarian Internet Exchange, so they're going to host us next time at RIPE 93. Unfortunately, they're not here anymore. However, they have asked one of our Bulgarian colleagues to come up here and tell you a little bit about Bulgaria and what to expect. Okay, Gana, please come up.
Thank you, Miriam. So it's such a great pleasure for me to invite you all to Bulgaria. Finally, the right meeting is coming to my country. The venue is the Grand Hotel Millennium Sofia. It's a really big venue. The hotel was finished about 7 years ago, so it's still quite new. Big conference facilities, a lot of rooms, and it's also relatively close to the city center. I wanted to also share a few things about Bulgaria for those of you who are not very familiar with the country. So you see an image of yogurt on the screen. Why is that? So Bulgaria has a very long tradition of creating yogurt, and also the bacteria that turns milk into yogurt was first isolated and in Bulgaria and named after it too. Bulgaria is also the birthplace of the Cyrillic script. It was invented in the 10th century in the Preslav Literary School. Preslav is one of our older capitals. Last week, Bulgaria won Eurovision, but the country is also very famous in the music world because of our folklore, because it has many unusual vocal harmonies. I'd advise you to take a listen. There's also a valley in Bulgaria that has the perfect conditions for growing roses. So that valley is responsible for 80% of the world's production of rose oil, which is used in perfumes. Something that I found out recently about my country is that it's famous also in the fitness world. And just in specific, an exercise called the Bulgarian split squat that you can see on the screen. It comes up in every fitness video, apparently. I see some people know about it. And lastly, for those of you who are planning a trip, I would like to explain our head gestures, which are different than what the rest of the world is used to. So when we say yes, there is a bit of a head wobble like this, which looks like a no for the rest of the world, but it's a yes for us. And then when we say no, we do something like a head nod, but you have to start it from low. So it's no. But when you do it multiple times, then it looks like you're nodding. So that's confusing. It is what it is. It's what we do. A little bit about Sofia. It's a very old city, like most cities in Bulgaria. I'd advise you to visit the Serdica archaeological complex. Serdica is an old name of Sofia. And there you can see buildings from different millennia in basically sharing a single photo frame. And also the archaeological museum, the National Archaeological Museum. It's fantastic, definitely worth a visit. Even if you're not a big history fanatic, but for the fanatics, there's more museums of history that are on the screen. And then as soon as you land in Sofia, you're going to notice a big mountain towering over the city. For those of you who enjoy nature and active hikes, I have listed 2 suggestions. One of them is from Alekohad to Chernivrh. Chernivrh is the highest mountain of Vitusha. Highest peak of Vitusha. And then there is another circular route, Bojana Church to Bojana Waterfall and Bojana Lake. The Bojana Church is also a UNESCO heritage site. It's a very, very nice and green route to relax for half a day. Apart from that, some other sites in Sofia, a lot of the foreigners remark about our churches. So the Orthodox churches are quite different than what you would see, for example, in Catholic or Protestant ones. So if you haven't been in one, I definitely encourage you to go and visit. The Alexander Nevsky one is the biggest one, but there are plenty of other ones throughout the city. And also, please reach out to me if you would like to plan any weekend trips or longer tours. There's plenty to do in Bulgaria. But yeah, that's what I have time to share with you now. And I want to hand back over to Miriam.
Thank you very much, Kagan. It's always good to hear somebody who's actually been in the country or comes from the country, you know. So I hope you feel encouraged to come to Bulgaria. Before I move on, I forgot one thing always. I always forget something in the closing. I need to thank our platinum sponsor, AWS. I don't know if some of you are still in the room, Clara or Tina. Otherwise, we'll ship this to you. And our Clara is here. Great. Sorry about that. I was rushing through the slides to not run over time, but apparently that's the thing. I want to take a picture. Thank you. Thanks, Clara. And finally, this is the closing. Please join us for RIPE 93. The registration is already open. You can register. I think already some registrations I already saw come in. I hope to see many of you there in October. And that's it. Enjoy lunch. Wait, there are these strange people coming, making their way up to the stage. I think there's still something happening. Wait.
Bing bong. Would attendees please make their way to the appropriate room? The secret working group session is about to begin.
Thanks, Al. Good morning. It's been a long week here, and I'm not entirely sure. I've got a wee thing in my throat at this point. So I'd like to welcome you all to Old Reiki Beyond the Wall. I have no idea what that says because I only speak English. Yeah, the usual applies. But sorry, it has been a long week. Welcome to the Secret Working Group in Edinburgh, Scotland. So a little bit of the usual thing. This is the Secret Working Group, and that means, and it bears repeating apparently every single time, that means no pictures, also not from you, Ivan. That means no text messages, no Facebook, no Telegram, no Twitter, yes. No YouTube, no Instagram, no TikTok, no WhatsApp, and certainly no why. I need to update this slide. But also, given that it's now 2026, it also means no DeepSeek, no Grok, no Claude, no Gemini, and no ChatGPT. Fine. Okay. Well, where to start? Let's start at the start of the meeting, shall we? A marquee presentation. Who wants to do this one? Jan, you want to do this one?
A marquee presentation. There are things you can do with marquee, and they are fun, as I'm sure you will agree. They can drift to and fro and can show high and low. What a poetry payload you see.
I think the next week's you, Francisca.
Housekeeping. Don't forget, we are a proper working group, so here's our housekeeping section. We feel we need to talk about this as well because we follow community discourse very heavily, and we have to say we are at least as special as IPv6, so we need our own chair selection process. Remco, the working group chair, stirred up quite some despair, announcing intent to retire and select another to conspire. Certainly, the process will be fair. And also, I mean, we all know the most important topic everyone talks about this meeting is air quality in meeting rooms. So let's talk about the air quality in our room. The smoke in the room is less black, and the door has been opened and cracked. There's a little fresh air. And I think it's not fair to describe it as more of a shack.
Now on to more serious matters, and back due to popular demand, and it's been the single most requested thing in our survey, the return of Nigel for the sonnet. Nigel, the floor is yours.
With dread we ventured north to Edinburgh, not knowing what we'd find, but fearing ill. Not least because there's nothing rhymes with it. We know it's built on old volcanic hill. Expecting endless rains of porridge chilled, and iron brew of steel girders wrought. Instead we find delicate croissant filled. No need to go out for food that must be bought. And smiling ladies fill our cups with tea. Not quite Earl Grey, but pleasant nonetheless. And cake and biscuits, chocolate and free. And deep contentment leaves us free from stress. And jolly provost, girt with a gilded chain, who warmly welcomes us, will come again.
So now that we've covered that bit of classic British tradition, we'll move on to the great British tradition. And no, I do not mean Bake Off. There's a line, you know. Jan, you want to do this one?
There's a line. The dinners is always a classic. The food is quite often kick-assy. But way down the street, we are waiting to eat. We are queuing here since the Jurassic.
But, I mean, they let an awful lot of foreigners in here this week. And not all of us know how to do the proper British thing. Which, you know, I mean, not everything works out the way you want it to. So everyone for themselves. But lunchtime is when we have need to urgently, instantly feed, beginning by queuing, wait, what are you doing? And the line just became a stampede. Now, I've been attending RIPE meetings for, let's say, a while. And apparently, until this week, there was this part of the program that I missed. I entirely was oblivious to its existence, but it was apparently well advertised. And, you know, I appreciate the openness of this. I mean, this was Tuesday morning, where we were welcomed to the second plenary sex of the day. Not the first, the second one. With lots of fun talks with Brian and Clara. I mean, I hear a meeting plan update. I mean, that's amazing. Thank you. And then we had another unique thing happen. We had a voice from beyond. I think we had the first ever chatbot contribution in the microphone queue this week. Francisca, you want? I mean, it was your working group. So
A voice, neither flash nor afloat, asked the RIPE AP group, and I quote, "The swimming pool's wide, and the slash aids inside." The chair reached with care for the mute.
And then, of course, we had a lovely presentation from Tony Lee, who had a very, very early morning on remote participation and was faced with a room that was maybe not as appreciative of his presentation as he hoped. Bits in space. The internet's off into space. Addresses all over the place. So you can send out a ping with a block for each thing, and then wait 8 hours for the trace. And my key takeaway from Tony's comments at his presentation was, Earth is in space, which I never really thought about, but yes, that's actually 100% accurate, and the dinner venue last night very clearly showed this to us. There's also a better picture that the Artemis 2 mission gave us a couple of months ago, which is my new favorite astronomy picture, which is this one, the Earth is in space. This is the Earthrise picture that was taken by the NASA astronauts. And of course, we had to send people across the back of the moon to make this picture. Quite a bit of an endeavor. But I was looking at the venue last night, and I mean, they also could have just booked a ticket to Edinburgh. What else? We had an IETF BOF on Monday night. No, Drew, you're fine. And that went, and there was some feedback to the IETF, and at the IETF BOF, a comment was made by a certain Mr. Reed, and his comment was a little bit to my surprise, and I think everyone in the room surprised, not so much about the content, but the dislike about the IETF's working group names, especially the poor taste in acronyms. And I mean, I'm not going to say he's got a point, but there is definitely something to it. I've seen the IETF working group names, and it's lacking a little something. So the secret working group has taken this up with the IESG. And we've decided to rename the new JSON schema working group. And it's going to be the Jim Reed working group, which is... And I will read it out. JSON issues mostly resolved earlier in DNS. Charge. Nigel.
The money appears as by magic. The method is secret, it's tragic. We've no charging schemes, and despite all our dreams, the option we chose is pelagic. Now, for those of you whose English is not, where English is not their first language, I have two things to say. One is it's almost impossible to find something that rhymes with magic and tragic. And secondly, pelagic means all out at sea.
And then a flashback, unexpectedly, all the way back to 1993. For those of you who remember, I have very, very vague recollections of my first year in university. And it was sort of the origin of, I think, the first internet meme on record. And it was a cartoon in the New Yorker. And it was this one. It's on the internet. Nobody knows you're a dog. You've all seen this one, obviously. You've been on the internet, I've been told. I would also comment that 1993 was the era of low-resolution scanners. I've tried to find a better picture of this online, but unless I spent $175,000 for the original, there was really no chance of me getting something better. Now, this cartoon has been revisited about a decade later. Which is this one, which is remember when on the internet nobody knew who you were. And now, thanks to things like the UK's Online Safety Act, or whatever it's called, we're actually requiring the dogs to wear tags now. Right. What else do we have? We're almost through, I think. A tight squeeze. Jan, you want this one?
10 minutes, no more, for a lightning talk. But the queue for questions might make you balk. When time's running short and the next speaker is looking fraught, the chair needs to ask them to walk.
I mean, there's a sequence to this. Apparently, this limerick was written early in the week, and then there was a later submission, which was this one. Cut off. When remote questions run on, and the speaker declines to be gone, you can mute them at first, but then at the worst, hang up and withdraw the renom. So I think that concludes what I've got to say. I guess I'll see you next time in Sophia. Oh, this is the Disney princess. So let me try again. I mean, doing a Google image search for Sophia is absolutely horrendous. So see you next time in Sophia. One of my favorites. Queen Sophia of Spain, obviously. Sophia Loren from Italy. Okay, one more. See you next time in Sofia, Bulgaria.